Assalamu alaikum. Today we will discuss some problem and example in heat and first law of thermodynamics. Even for ideal gas, example 1, if we have 100 liter of oxygen at 25 Celsius and absolute pressure at 380 m is compressed to volume 60 liter, while the temperature increased to 60 Celsius. Calculate the new pressure. Okay, how to solve this problem? Knowing this, we would like to determine the new pressure inside the gaseous container. Then we have a container, and inside the container we have the gas. So we are assuming that no gas is allowed to leave or enter the container during this compression. And so the number of moles of gas remains constant. So we need to apply the ideal gas law to calculate the new pressure of the container. So we have system 1 at 25 Celsius and it's compressed to 60, uh, 60 Celsius as in system 2. إذا ideal gas law BVV تساوي NRT. إذا BV over T بتساوي NR and NR is constant. إذا we have the number of mole is constant. It remains constant. So B1 في B1 على T1 تساوي B2 في B2 على T2. إذا B2 تساوي B1 في V1 في T2 على V2 في T1. إذا B2 تساوي B1 is 380 amp ضرب 100 liter and we convert 60 Celsius to Kelvin 273 زائد 60 كلفن على 60 لتر مضروبة في 273 زائد 25 كلفن، لأنه T1 تساوي 25 سلسيوس in Kelvin we add 273. النتيجة the pressure P2 equal 5.6 atm. Another problem or example, a certain container can withstand a pressure difference of 180 m pressure before collapsing. The container is initially at 280 m and temperature of 20 degrees Celsius. If the volume is to remain constant, to what minimum temperature can we cool the system before it actually collapses? إذا we have container B1 at 280 m T1 20 سلسيوس زائد 273 تعطينا بالكلفن and we want to cool this container, so we have during the cooling the atoms it will be down, so B2 180 m and T2 how much? To solve this problem, we need to apply the ideal gas law while keeping the number of moles and volume constant. Now, number of moles and volume is constant. So, BPV تساوي NRT. Then B على T تساوي NR over V. And BNR over V, this is constant. So B1 على T1 تساوي B2 على T2. إذا T2 تساوي B2 في T1 على B1. إذا T2 we substitute T2 and which equal 146.5 Kelvin and in Celsius تساوي ماينس 123، 120.5 سلسيوس، لأنه 273 ناقص 146 كيلو. Okay. Another example, we have a certain container has a volume 600 meter cube and its standard pressure. Then, when set standard pressure, this means 180 m. What is the total mass of air inside the container at 25 Celsius? And we have assuming 80% of N2 and 20% of O2. Okay, we are asked to calculate the total mass of the air, composed of 80% nitrogen and 20% of oxygen inside a room or container that has a volume of 600 cubic meter. Assuming that the temperature of air inside this container is 25 degrees Celsius at room temperature, we can use the ideal gas law to calculate the number of moles of gas inside the room, and we can then determine what fraction of this number are nitrogen molecules and what fraction are oxygen molecules. To calculate the mass that each respective molecule takes up, we need to multiply the atomic mass by the number of moles and then add it up the two quantities. Okay, first of all, we have to determine the number of moles. From the first, from the ideal gas law, BVV بتساوي nRT. إذا N تساوي BV over RT. إذا standard pressure هذا يعني إنه 180 m. Okay. And the volume 600 meter cube. R is constant, gas constant 8.314 joule لكل مول Kelvin, and at room temperature we have 25 Celsius, and Kelvin we have to add 273 Kelvin, so it's equal 298 Kelvin وتساوي 24500 مول. طيب N of oxygen تساوي هي 20%، 0.2 ضرب 24500 وتساوي 4900 مول من الأكسجين من O2. أما النيتروجين فبيحكي لي إنه 80%، إذا 0.8 ضرب 24500 وتساوي 19600 مول of N2. طيب total mass of oxygen O2، هذا يعني عندي ذرة الأكسجين 16 إذا كان عندي O2، وهذا يعني 32. إذا بدنا نحولها 32 جرام لكل مول ضرب 4900 مول، مولز مع مولز، فالنتيجة بتصفي 156.8 كيلو جرام. أما التوتال ماس اوف نيتروجين، النيتروجين 14 انتو بتساوي 28 جرام لكل مول ضرب 19600 مول وتساوي 548.8 كيلو جرام. التوتال ماس إذا 156.8 كيلو جرام زائد 548.8 كيلو جرام تساوي 705 كيلو جرام. Okay. Example in the first law of thermodynamics, determine how much work is done by a pump to isothermically and slowly compress 3 liters of an ideal diatomic gas O2 at 0 degrees Celsius and 180 m pressure to volume of 1 liter. Okay, then عندنا 3 liter we have to compress to 1 liter. Solution. To solve this problem, we have to determine the work. We must utilize the first law of thermodynamics, which states that the change in internal energy of our system is equal to the heat flow into system minus the work done by the system on the surrounding. Since we are dealing with isothermal process, the change in temperature is zero, which implies that the change in internal energy is also zero. This means that the heat flow into system is equal to the work done by the pump on the system. If we integrate and use the ideal gas law to replace the pressure with volume, we can determine the equation that will allow us to determine the quantity of work done by the pump on the system. However, before we use equation, we must use the ideal gas law to determine the number of moles of gas inside our system. Then we have from compress from 1 to 2. This is the pressure and the volume, and we have to compress, and it's isothermal from 1 to 2. So delta E internal equal first law of thermodynamic تساوي الهيت plus the work. لكن بما انه بيحكي لي انه ايزوثيرمال وبنعرف انه دلتا اي انترنال فور داي اتوميك بتساوي 5 على 2 مونو اتوميك 3 على 2 ان ار تي دلتا تي داي اتوميك 5 على 2 ان ار دلتا تي. And because it's isothermal, delta T equals 0. Then delta E internal equals 0. So Q equal minus the work. وبنعرف إن الwork تساوي الانتجرال from 1 to 2 ل dw وتساوي الwork بيساوي from V to V2 ل B dV. لكن بنعرف from the ideal gas law PV تساوي nRT. إذا the pressure equal nRT over V. بنيجي نعوضها هون. work تساوي V1 from V1 to V2 ل nRT dV ل V وتساوي nRT from V1 to V2 ل dV على V وتساوي nRT في لن ال V وتساوي nRT في لن ال V2 على V1. لكن what is the number of moles؟ إذا لازم نحسب ال number of moles. عندي V1 تساوي 3 لتر، P1 تساوي 180 أم، V2 تساوي 1 لتر. إذا V2 how much؟ N تساوي B في V على RT. أوكي، إذا N نعوض B في V over RT على كل number of moles it remains constant بغض النظر عن البريشر P1 or P2. So we can use P1. إذا وتساوي 0.113 moles. نيجي نعوضها بالمعادلة هون N.13 and R is the constant gas and T is a temperature فلن V2 على V1 اللي هي we compressed from V1 to V2 لكن V2 اللي هي 1 واحد and V1 equal 3 فالنتيجة تساوي minus 324 جول. So the quantity of work done on the system negative. هذا يعني من ال quantity of work done on system by the pump. Okay. Another example. 2 moles of monoatomic ideal gas expands adiabatically inside a container from some initial volume to some final volume. While the ideal gas expands, it does 8,000 joule of work in the surrounding. Determine the change in temperature of the ideal gas during the expansion. Okay. To solve this, we must apply the first law of thermodynamics. Since we are dealing with adiabatic expansion, this means there is no heat flow into or out of the system. Therefore, the change in internal energy is equal to the work done. Since the gas expands, work is done on surrounding and the internal energy of the system decreases. So we have the container and its expand adiabatically expandance. So delta E internal تساوي Q زائد the work. وبنعرف إنه adiabatic إذا ال Q بتساوي زيرو. So delta E تساوي the work. Internal energy lost by the system is gained by surrounding through the work done by the system. Work done by the system on surrounding. Okay, so delta E internal, and we have this monoatomic. This means 3 N R delta T over 2 وتساوي the work. إذا delta E internal تساوي 8000 جول في number of moles 3 في N في R على 2. This means delta T 320 Kelvin. Okay. Okay, this is some examples and the problem in this lecture, and also next lecture we will continue by other examples in heat and ideal gas. So thank you for your attention.